Good morning, students. In this concept 9, we are learning about free body diagram. Free body diagram is one of the technique. It is highly useful in working with Newton's laws. Here we have to follow some steps for solving of the problems in Newton's laws. Free body diagram is one of the technique. It is highly useful in working with Newton's laws. So, what are the steps involved in free body diagram? Repeat చేస్తున్నాను సార్ వర్డ్ ఓకే అంటే సేమ్ వర్డ్ని రిపీట్ చేస్తున్నాను అంటే కొంచెం టర్మినాలజీ రిపీట్ చేసుకుంటున్నాను కట్ చేసేస్తారు ఇది ఓకే Shall I start, sir? Good morning, students. In this concept 9, we are learning about free body diagram. Free body diagram is one of the technique is useful for solving of the problems in Newton's laws of motion. So here in this free body diagram we are following the steps. What are the first step? In this one we are deciding the system. For example, two blocks A and B are in contact. I applied a force on the system on the block A. So now it is a frictionless surface. Now the blocks are moving with the same acceleration. Now your choice is decide the system. Here you can take A as a system or B as a system or hold together A plus B also as a system. So here, but I am taking your wish A plus B you can take as a system and A also you can take as a system and B also you can take as a system. That is our wish. So in solving of the problems, first you decide the system. So here this is I applied force on this total two block system. Now you can take A individually as a system and B individually as a system or A plus B together as a system. But what is the condition is the system which one we are deciding, the system must possess same acceleration. That means, for example, now this is two blocks A and B are connected to a string at the end, connected to the ends of the string, and they are passing over a pulley. Now all of you know it is a frictionless surface. This block is moving down and this block is moving along this direction. Now, how much length covers this body per unit time? The same distance covering by the body A the same time. So now this one how much acceleration having, this body also having the same acceleration, but we don't take it as a system. Why? Here the block B how much acceleration having, this body also having the same acceleration? No, this body magnitude of acceleration and this body magnitude of acceleration only same, but the acceleration of this body is in this direction, the acceleration of this body is in this direction. So now their directions are different. We don't take A plus B together as a system. You have the right to take A as a system or B as a system, but you don't take A plus B as a system. So here, but here we can take A plus B as a system and A as a system or B as a system. Why? Because of A plus B together how much acceleration having, and B individually we are taking that one acceleration and A acceleration are taking as a system, all they having the same acceleration. That's why A plus B we can take as a system, and A also we can take as a system, and B also we can take as a system. So this is one of the first important step in working with a free body in free body diagram. Next, second step, identify all the forces acting on the system. That means now we decided three cases. One is we can take A plus B as a system, and also we can take A as a system, and also we can take B as a system. Now the forces, all the forces you have to identify the forces which are acting on the system. So now we are taking A plus B whole as a system. How many forces acting on that system? There are this total together on this one downward MA plus MB into G. This is the force acting in downward direction. Now another force on this one, normal reaction Na plus Nb acts on the system by the surface, and also on the system external force acting F bar is in this direction. Now say to me, A taking as a system, what are the forces acting on the system? Now what are the forces acting on the system A? The forces acting only A, as we are considering A as a system. Now on this A, the force acting MAG in downward direction and normal reaction acts in upward direction, and also the force, applied force acts in this horizontal direction, and another force also acting. What is that force? The two bodies A and B are in contact. There will be a normal reaction developing by the body A on B, and the body B also same equal and opposite force develops on A. Now we are taking A as a system. You have to consider the forces acting on the system only. So now on this A body, the force developing by this B body on this A, that is in this direction, that is NBA, the normal reaction developed by the body B on A. So next, if we are taking B as a system, how many forces acting on that one? So here only B we are taking as a system. MBG acts in downward direction and normal reaction developed by the surface in upward direction, and the force acting on this body B is only the force along horizontal direction, is only the normal reaction developed by the body A on B, that is in this direction. Now, after identifying all the forces acting on the system, here what is the condition is, the forces acting on the system only you have to consider, but you don't consider the force developing by the system on the other bodies. So that is very, very important instruction. Now, after this one, you have to represent all the forces. You treat entire system as a one point and represent all the forces vectorially on that system. That means MA plus MB into G in downward direction and NA plus NB in upward direction, and applied force in this direction. Similarly, the force acting MAG in downward direction and NA in upward direction, and applied force in this direction, the force developing by the body B on A is in this direction. Similarly, for the B as a taking as a system, MBG acts in downward direction, normal reaction in upward direction. The normal reaction developed by the body A on B is in this direction. Now, this is a very, very important. Here, identifying the forces is very, very important for us. So, deciding the system is a first step, and another step is identifying all the forces acting on the system. Next, third step, choose the coordinate axis. Now, in our solving problems, in general we are using the coplanar forces. Now, the forces acting along x direction and y direction. After separating the forces along x direction and y direction, you have to apply Newton's second law in the on the system, that is all the forces acting along x direction. For example, we took A as a system, A plus B whole as a system. Now, I will write separately. Now, see here, A plus B acting as a system we took on A plus B, along x-axis direction. How many forces acting? Only one force acting. That is sigma fx is equal to f. That f is not equal to 0, nothing but if f is not equal to 0, sigma fx is equal to max. What is here mass? Mass of the system. That means mass of the system is nothing but a plus b. What is that mass is? F is equal to ma plus mb into a. Next, along y direction, now the force acting in y directions are ma plus sigma fy is ma plus mbg is downward direction and na plus nb is in upward direction. Now na plus nb minus ma plus mb into g. So now if you know that the body is not going in downward direction and as well as not in upward direction, the net force along y direction is 0. So Na plus Nb is equal to Ma plus Mb into G. Similarly, for the system A, what about the system A? In this system, what are the forces acting in along x direction? Sigma fx is equal to, now f minus NBA. F is acting along positive x direction, NBA acts along negative x direction. So that is also not equal to 0. So then F minus NBA is equal to MA into A. Similarly, sigma Fy, the forces acting along y direction. Now, what are the forces acting along y direction? The NB is acting along upward direction, NA acting along upward direction, and MAG acting along downward direction. And all of you know, the block A is not going along upward direction or in downward direction. That's why net force along y direction is 0. Similarly, we are treating block B only as a system. Now on that one, sigma Fx is equal to, what is the force? Only one force is acting, that is normal reaction developed by the body A on B, that is only acting on that system. That is not equal to 0. That implies NAB is equal to MB into A. Next, sigma Fy. Sigma Fy, the forces acting along y direction. NB is acting in upward direction. MBG acts in downward direction. That equal to 0. Why? Because the force acting in upward direction and downward directions are equal. That's why this block B is not moving along y direction. So that's why this force and this force magnitudes are equal. Next, sir, place is not sufficient. Okay. Now, another important one. For example, a block placed in a lift. Now, one of the observer is in the lift and another observer on the ground. Now, the lift is at rest. What we are saying, the force acting on the body is normal reaction mg acting in downward direction and normal reaction acts in upward direction. Now, the normal reaction, the observer here is saying N is equal to mg, and the observer in the lift also saying the N is equal to mg. Now, another one. In this one only, if for example, if the lift is accelerating upward direction. Now, once again say to me, what says the observer on the ground? The observer on the ground, what he says, and observer in the lift, what he is saying. Now, observer on the ground, what he is saying is, the lift is accelerating upward, the normal reaction is a dominating force and mg is less force. Now, N minus mg is equal to ma, net force acting on the system is equal to mass into acceleration. So, what he says is N is equal to mg plus ma. Now, the person in the lift, what he says? Now, for the observer in this lift, he says, for him the block is appearing to be at rest, and he says upward force and downward force are equal. Once again, he says N equal to mg. We got one contradictory result, contradiction we got. What is that one is? The observer on the ground saying one answer, the observer in a lift saying another answer. That is, which one is correct among these two, between these two? Which one is correct? Is the, according to the practical observations, the observer what said in the ground is the answer only correct answer. So here, this answer is a wrong answer. Why? Because of what saying is Newton's laws are not holds good in non-inertial frame or accelerated frames. So here to apply the or to valid Newton's third law, Newton's laws of motion in this accelerated frames or non-inertial frames, we are including one extra term that is called minus ma. That minus ma is, m is mass of the block, a is acceleration of the block, acceleration of the lift. So minus ma is opposite to this one. The observer is moving along this direction. You have to take a one term that is minus ma. What is m? Mass of the body. What is a? Acceleration of the observer. That is minus ma. If you are taking, you are getting the same answer. That means, see here, the observer is applying this extra term, that is n minus ma is equal to mg. Then he says mg plus ma. Now he also got the same answer. Now from this one, the observer in that accelerated frame, we are to apply Newton's laws, we have to include one extra term. That extra term is called minus ma. That is only we are keeping one name, that is pseudo force. That is pseudo force. So here, to apply the Newton's laws in non-inertial frames, we are adding one extra term called pseudo force, so we can solve the problem in non-inertial frame also. Okay, so that's why in the first step, decide the system only we said. Before only, first important is reference frame. For that reference frame, see here the reference, the observer here saying one answer, the observer saying here is another answer. So here very important another step is choosing of the reference frame. The observer is where? If the observer is in non-inertial frame, he has to add one extra term called pseudo force. If the observer in the inertial frame, he has no need to apply anything. So very important step. First, you are taking the one block as a system or one system. The very important point is reference frame. So next only we are saying that decide the system and identify the forces and choose the coordinate axis and applying the Newton's laws. So it is about the concept 9. Thank you.